Okay, again, okay, in terms of the Taylor series here, okay, so this is the xt, the first function, okay, the first function xt, for example, plus h, the time step of the function of tx. Okay, this is the simplification of the Taylor series based on Euler. Okay, so if you can see here, for example, so you have a x function of x on t1. So function of x of t1 is a x of the function t nodes, the original or the initials, plus the time step. So it's equal to x of the function of x at the initial, okay, the function of x initial, plus step function of the function of t node and x node. So when you go for x t2, so you can see here x is the t2 value, okay, plus hf t1 x1, then t3 you get the value previously x t2 plus h t2 x2. So means that it calculate based on the previous value, then you need to add the function of the with the time step, then you get the next value. Okay, this as an additional of representation, we should adopt the convention of this one lah. Okay, so the advantage of viewing Euler method as an application of a Taylor series in this way is that it gives us a clue to obtain more accurate method for numerical solution of differential equation. So it's also enable us to analyze and more detail on how accurate Euler method. Okay, so we can abbreviate based on this one. Okay, where is x t plus h equal to xt, the first functions, plus the time step times the function. Okay, then the oh square, which is oh square cover all the terms of h greater than equal. So by combining this, so this is the final of simplification of the equation. So equation 10.26, which is this one, okay, is express facts that each of the step Euler for x t plus h and obtain an error of order h square. So to put it another way, the formula used in accurate as far as the term of h. So the reason of this reason Euler method is known as the first order method. So the exact size of error is, and we intuitively expected depending on the h, the time step, and decrease of as h decreases. So since the error of order h square, we expect that the halving of h, for the instant, we reduce the error of the factor of 4. So this does not, unfortunately, means the error of solutions of initial to further a factor of 4. Okay, so okay, maybe we can go for example here, okay, to make things clear. Okay, for examples, okay, let xa denote the approximate of solution of initial problems of the function dx over dt is x squared t plus 1. When xt is 0, your answer is 1. So obtain Euler method with the step size of h 0.1 for xa, and xb is time step of h 0.05. So then you need to compute of xa, t, xb for t equal to 0.1, 0.2, and the rest. So then they compare the value of xt, the exact solution of the problem, and compute the ratio of error. This is compute the ratio of error xt and xb. Okay, so there is a several steps. First, you need to find the value of xt with the time step of 0.1. Okay. Second, you need to find the xb with the time step of 0.05. Then you need to calculate until the time step of t from 0.1 until 1.0 for each one, and also xt value. Okay, the xt value. Then you need to find the error. So in order to do this one, so it's easier for you to do in a table form. Okay. Very correct. Okay, so first of all, in these examples, what you need to do, you have three main things, which is first you need to find XA, second you need to find XB, third you need to find XT. Okay, we go for XT first. XT is the integration of the function of dx over dt, integration of this one. You integrate this one, you will get something like this. Okay, back to integration. Okay, this is, in order to integrate this one, you need to integrate in terms of dx and dt lah. So this one, so it become dx over x square is equal to dt over t plus 1. Okay, just to be remind, most of you have make a wrong in your test. Okay, if integration of dt over t plus 1, so this one you can get a ln t plus 1. But you must make sure the t is power of 1. If your integration is dt divided by t square plus 1, you cannot put it ln t square plus 1. So it's wrong. Most of you do that in your test. This is wrong. So you must make sure if 1 over t, the power of t is power of 1 only, then you can do it for ln. So this is the basics. Hopefully you need to check lah. For example here, integration of this one, you can get ln t plus 1. Integration of x square, you cannot get ln x square. So it's wrong. Okay. So once you integrate this one, you will get the value of x of this one, which is x is equal to 1 over 1 minus ln t plus 1. Okay. So this is the value of xt, this one. Okay. So in order for you to answer the questions, you need to do this table. Okay, you can, easier for you to use in Excel especially. Okay, on this one. Okay, so you start with the initial. We know that initial here, when xt0 is equal to 1. So t is 0, 0.00, xa is become 1, xb also become 1, xt also become 1. Okay, you start with this initial. This is, we call it as an initial. So xa, the h value is 0.1, xb, the h value is 0.05. So xt is based on the integration of the xt, which is xt is equal to 1 over 1 plus ln t plus 1. Okay. Yeah. 1 minus, sorry. 1 minus. Okay, 1 minus. Okay. So you can do it in Excel. Okay. You can do it in Excel in order for you to get this one. Okay, how to calculate this one? Okay, we start with XA first. Okay, XA, okay, in order to get this value, okay, so you need to calculate the XA. So XA is, for example, we do it here. The second access value is X node plus HF T node X node. So you will get this one. So now, in order to calculate this one, okay, so what is your X node? X node is 1.10. Okay, this one. Plus what is your H? H is 0.1. What is the function? The function is based on the dx dt. Okay, just now your dx dt is x squared divided by t plus 1. Okay, so you put it here and okay, dx dt is x squared divided by t plus 1. Okay, so this is the function of x squared. What is your x squared here? Is x squared is 1. Okay, 1. This one, the previous one, the initial one. Okay, 1 square divided by, what is your t? T is 0. What is your plus 1? Okay, so from here you will get the value of 1 square divided by 1 times 0.1. So you will get the value of plus 1.1 is become 1.21. Okay. So this one you will get 1.210. So this is the value of this one. Okay. So in order to calculate this one, you need to continue using 1.21. Okay, plus, okay. In order to calculate this one is, okay, where are we? Again, the internet are not stable here. Okay, hopefully you get it. In order to calculate the xt or the next one, you need to use this one. Okay, same for the xb. Okay, xb you need to use by using the h equal to 0.05. Okay, so use the same one method. xt, you just put it your value in terms of this one. So for example, the second one, so your t is 1.1. So 1 divided by, okay, this one, it will be 1 divided 1 plus ln. What is your t? T is 0.1 plus 1. So you will get this value. Okay, so the question asks you to find the error. Okay, you normally this Euler will help you to find the error. So the next column will be x minus xb. So this is your x value. You need to minus the xa. So you get the 0.0535. Then second one, x minus xb in the modulus, 0.02585. Then you divide it both, you get the error analysis of the functions of the xb and xa. So you need to calculate this one until the question asks you to finish it by t equal to 0. Sorry, t equal to 1. Okay, hopefully. Okay, so you need to calculate this one. Okay, in order for you to get all this answer. So in order for you to understand well, okay, I want all of you, okay, this is Euler. Okay, I want of you do an Excel, okay, as your task. Okay, what you need to do is, I'll show you the example. Can you see my Excel? Can you see my Excel?
Yes, doctor.
Okay, can you see my Excel?
Yeah.
Okay, so okay, what you can do here, in order for you to understand the Euler formula, the examples, okay, you can calculate manually, but this is another way of you to answer this one. Okay, if you can see here, yeah, we go for one by one. So t is 0.0, 0.05, 0.1 because of xb is 0.05. You see h here. So XA is we start with the first one. This is the initial one. So T is 0, C is 0. So XA is 1. Okay, the initial one. XB is 1. So X A square, and you remember the function is x square divided by T plus 1. So what you can do, you do it x square, then you do it xb square, you do it T plus 1. Then you can do the function of FA, function of FB. So when it function of HFA, H is a time step, HFB, then you can get the answer of I plus 1. Okay, so if you can see here, this is the function lah. Okay, before we go the absolute of the error. Okay, so what you can do when 0.05, the first time step, okay, this step is 0, then 0.05. X is there is no 0.05 because it starts 0.1. So XB will affected. So what is XB? XB become 1.0501. Okay. So 1.01 but then you need to use this your function x squared divided by t plus 1. So what is your xb square? You square this one. So then t plus 1, then you can get the function of fb is a divided x square xb square divided by t plus 1. So you get the fb. Okay, then then you can get the step size here. Okay, you can say 0.035. Where is your which is your this one h times h, fb times h, and h 0.05 times the function, you will get this one. Then you will get plus with the previous one 1.1, you get 1.0. So you will get this one 1.0125. Okay, so next is 0.1. So you see here this 0.1. When you calculate, you will get what is your xb, what is your xt. So this is your xb, which is 1.21. You can see it 1.21. Then another one is 1.216. Okay, so you try to do it this calculation using your Excels in order for you to understand how this xa xb is calculated. Then you find the error by minus this one and find the divided of the absolute of this one. Okay, so I want you to do it. Okay, then for your understanding on how the Euler function presented. So how this, try to find the exact, you need to find the exact value on how to get the xb on time step of 0.00, 0.01. Okay, and xt based on the non-function here and the error. Okay, I want you to replicate this one by using your Excel and make sure you understand it, because your test will be the next test. For example, we give you function, you need to calculate, okay, from the based on the time step here. Okay, so that's a Euler. Okay, we go for the next one is a Runge Kutta. Runge Kutta, we try to finish Runge Kutta. This is another method also in order to find the error analysis. So most numerical method is you need to find, normally used in calculation of the results of previous based on the time step in order to see how accurate of that results. You have a numbers of results, then you want to find the error analysis of the result. So you can use the Euler method, and you can also use the next one, for example, Runge Kutta. Runge Kutta. Okay, what is a Runge Kutta? Is general principle of Runge Kutta method can be explained informally by a graphical argument. Okay, so for example, in the next figure shows a grammatical interpretation of second order predictor corrector method introduced in the last session. So the starting point for Tn xn, point A in the diagram, the predictor of xn plus 1 is calculated. If you can see here, for examples, you have a xn here. So your A is xn Tn. So this one is xn Tn. Okay. Tn. So B will be something around here. So this one will be affected based on the time step h of the function of Tn xn. Okay. So for example, B to C, so it become the plus of Tn plus 1 xn plus n. So in terms of the function, it's f Tn plus n xn. So means that it average on this, in between it average it become the calculation. Okay. Okay, means that the line of AB has a gradient of f Tn xn. So the ordinate of the B is prediction of xn plus 1. So then the next line is a AC, is a gradient of f Tn plus 1 and xn plus 1. Then the gradient of the direction field is equation of B, and so C as an ordinate. Okay, so it's calculate on the average of from this one to this one. So this is the function step function of the step and also the function. For example, C and B, so they calculate in half of it, so you will get the equation lah. Okay, so we go for directly. What is the summarize of Runge Kutta method, which is extend the principle by using the gradient at the several point. It's a gradient calculation of the several point in order to estimate the average gradient of the solutions. So the most commonly used Runge Kutta method is a first order. Okay, in order to calculate this Runge Kutta, you need to use this calculation. So you should have a C1, which is your H. H is the time step. Find times the function of initial function Tn and Xn. Then C2 is a H time step of F Tn plus 1 over 2H Xn plus 1 over 2 C1. Okay, you need to calculate C1, you need to calculate C2. Then C3, what is the function is the step function H of Tn. Okay, the n plus 1 over H, 1 over 2H, H is the step function. Then the function of Xn plus 1 over 2 C2. Then the C4. Okay, then the rest of the Cn plus 1. Okay. So in order for you to understand how to use it, okay, this is more explanation. So we go for the examples. Okay. So this is the same example of questions, which is the function is the same, x2 divided by t plus 1 when x0 equal to 1. Okay, so for example, let xa denoted of the proximal solution of initial value. This is your initial value. This is your function. So you need to obtain using a first order ordinary Runge Kutta. Just now is Euler method. Okay, so with the h as a 0.1, the first step function, xb, the second step function is 0.05, and compute until 1.0, t until 1.0 from 0.1. Then you need to find the error, ratio of error xa, xb. Same questions, but using different method. First of all, you need to integrate the function in order for you to get the obtain the x value, xt. So you integrate the same one, you will get the same one. Okay. So next, you need to find xa, xb, similar like previously, but different method. So this example show the first that Runge Kutta scheme being a first order scheme as considering smaller error in absolute terms than any of the other methods we have met so far. Means that Euler method is more on power of 2 order, but Runge Kutta is a first order scheme, so it's more details of the calculations. So the second expression, we have a goal error should be on OH power of 4. Just now, if you remember, Euler is OH of power of 2. So this one is more accurate because it's used the first order scheme. Okay. Okay. How to calculate this one? Okay, you need to use the Runge Kutta method. Okay. It's better for me to show you. I'm doing this in Excel for you to understand. Then I want you to do it in Excel for you to understand more details. Okay. Can you see the Excels? Okay. Nampak tak? Can you see the screen? Okay. If you can see here, in this solution of books is already simplified. Okay. This book didn't show you how to find the XA, how to find the XB, how to find XT. So you need to do by using Runge Kutta method. Okay. If you can see here, what I'm doing is first I calculate the XA first. Okay. The XA value. Okay. How I calculate this XA value. Then the second one, I calculate the XB value. Then last, I'll create this table. You can see it, XA, the same one. This is the final table. But you need to calculate first because you need to use the Runge Kutta. If you remember, just you can see just now, the Runge Kutta, you need to use this formula. C1, so you need to calculate C1, C2, C3, and C4. Okay. Then also the xn plus 1. So the next x plus 1. by using the C1, C2. So you need to find C1, C2, C3, C4 in order for you to calculate the answer of XA first. Okay, we go one by one. Okay, we start with the step function. So for XA, the step function is 0.01. So you can use this 0.01. Okay. Okay, better I use this one for you to see it. Okay. So if you can see here, okay, yes, please pay attention here how to calculate C1 and the rest. Okay, your function here in these questions, okay, your function here is dx over dt is equal to x squared divided by t plus 1. Okay, and t plus 1. So this is your main function. So in order to calculate the XA, so you need to calculate the C1 and the rest. Okay, so we go for the first function is 0. Okay, so t is 0. So XA is automatically 1 based on initial value. X square, XA square is 1 square is 1. Okay, t plus 1, this is t is 0. 0 plus 1 will become 1. Then this is the function of dx dt, which is xa square or x square divided by t plus 1. So become 1. And you need to calculate C1. How to calculate C1? If you can see here, C1 is equal to the step function h times the function. So what you need to do here, if you can see here, when I put it in Excel, so it's a h. What is h? h is 0.1. For example, 0.1 times, what is the function? The function is x squared divided by t plus 1. So in here, the function will become x squared divided by t plus 1 is become 1. So 1 here, so automatically you will get your C1 is equal to 0.1. Okay, understand? So easy for C1. So we go for C2. C2 is quite complicated, a little bit complicated. It's not difficult, but it's just you need to understand. If you can see here, C2, okay, is a h is the time step of function where is your tn plus 1 over 2h. So your t function, you need to add up 0.5 times the step function. And your x function, you need to plus with half of C1. Okay. So what you can do here for C2, okay, pay attention. Okay, in order to calculate the C2, this is the matrix formula. Okay, the C2 is, and simplified C2 is, what is your h? H is 0.1. Okay, so what is your function here? Okay, remember here, your x is x squared. So in this case, your t is, you need to add 1 over 2h. So what is your x? Okay, x here, okay, if you can see in the Excel here, this is x, okay, see here, x plus 0.5 times C1. Okay, so in this case, okay, you can see here, what is your x? Okay, x is 1. What is your x? X is 1. Okay, your x is 1, your x is 1, xa is 1, plus 1 plus half C1. So what is your C1? C1 is 0.1 times 0.5. You say 0.5 times G5. G5 is 0.1. So it become 1 over 2 times 0.1 here. This is your x. Then it becomes square here. Become x squared divided by t. So you can, what is your t? T is 0, but t plus 1 over 2h. So your t is 0 plus 1 over 2. What is your h? H is 0.1 plus your min t1. So this is the value of C2. So you calculate, you will get this value of C2. Okay. So mean you need to add up these two main function here in your this one, your main function, this one and this one. In terms of t, you need to add 1/2 of h. Okay, in terms of c, x, okay, x function, you need to add up half of c1. So you will get the value of c2. So we go for value of c3. Okay, what is the value of c3? So first is h. H is remain the same one, 0.1. What is your function here? What is your x? X squared. So what is your x? In this case, your x, you need to add 1/2 c2. So in this case, what is your x? Xa is 1. Okay, and make it 1 plus 1/2 c2. What is your c2? C2 is 0.1105. So you need to 0.105 square because of x square. Okay, divided by what is your t? For t need to add half of your h. Okay, what is your t? T is 0 here. Plus, what is your h? Half h, 1/2. H is 0.1 plus 1. So you will get the C3. Okay, so you will get the value of C3. Then you calculate the same one for the C4. Okay, for example, C4 here, erase it. Okay. So we go for C4. Okay, what is C4? C4 is h. What is h? H is 0.1. What is the function? The function of tn plus h. So what is your, okay, we go for x. X squared, just now is x squared divided by t plus 1. So what is your x? X is 1. Okay, but here is x plus c3. So 1 plus what is your c3? C3 is 0.1055. 0.1055 square divided by t. What is your t? Is 0. Okay, plus h. H is 0.1 plus 1. Then you get the C4 value. Okay. Okay, so the moment you get the C1, C2, C3, and C4 value, you can start to calculate for the next x value, which is x 0.1. So this is the initial value. Where is, you can see here in your Excel, you put it xn. What is xn? Is C5, the original C, the previous C, okay, which is your xa. Okay, we go for x, the next, okay, xn. In this case, what is xn? Xn is this one, the first previous xa, which is 1, plus 1/6. What is C1? C1 is 0.1, plus 2 times what is C2? C2 is 0.105. Plus 2, what is C3? C3 is 0.1055 something, and plus C4. C4 is 0.11 something. So then you will get the value of x, this one. Okay, then keep on repeating until you get the x value of, based on this one. Now, from 0 to 1.0. Okay, understand? Okay, so that's, you just finish your XA. So what you need to do, you need to go for XP, the same one, but your time step is 0.05. So you will get, you can see here, okay, if you can see the time step is 0.0, 0.5, 0.1, 0.15. But in the table for XB is just take the value of 0.1, 0.2. So if you can see 0, you will get 1. Okay, so here is 0.1. So they ignore the 0.5, so just take 0.1. So you get 1.105352, which is the same, 1.105352. So 0.15, they don't put it because they just put it 0.2. So you get 1.2297. So when you calculate, you will get 1.229745. But you need, in this case, you need to XB need to 0.5, because without calculating 0.5, you won't get the correct answer of 0.1. Without 0.15, you will get the calculation of 0.2. So in this book, they just simplified it. So I elaborate and explain to you how you get this Runge Kutta method in order for you to get this one. Okay, for xt is direct. Xt you get this from this 1 over 1 minus ln t plus 1. You just put the value, you get xt. Then you need to calculate the error, or x minus x1. Here is a time 10 power of 3. Why? Because of Runge Kutta is a power of 4. So the decimal point is very a lot. So then they just time power 3 in order to reduce the number of 0.00 something about that. So actually the same one, they simplified. So then x minus x a, you get the value, x minus xb, you get the value. Then in order for you to calculate the error, so x minus xb divided by x minus xb, you get 0.06. Okay, back to this Excel. I already calculated the xa. I already calculated the xb. Then I put it everything in the table similar like this one. So when t equal to 0, so I get xa is 1 here, xb is also 1, xt also 1. Then there is no error because of there is this is the initial value. So when we go for x 0.1, 0.1, xa is 1.105, which is the same one. Xb is 1.1053512, which is the same one. Xt, you just put it in the function, you get 1.1053512. Then you calculate x minus xb times power of 10 power of 3, you get the same one, 0.00455. Okay, then this next is 0.004. Then I divided it, I get the same one, 0.0682. Okay, so this is how to use to calculate the Runge Kutta. Okay, so Runge Kutta is a single step method in the sense that they are only required of xn, not the value of x of any step of prior to that. They are therefore entirely self-starting, unlike the predictor, character, and multiple. So Runge Kutta is proceed by effective creating sub-step within each step. Therefore, they require more evaluation of the function ft at each step and multi-step method equivalent of the order. So for this reason, they are computationally less efficient because they are self-starting. However, Runge Kutta method can be used in step process of multi-step. So this is in order to calculate the error. Just now, what we have learned is already 120. We have learned of using the Euler method and also Runge Kutta method with the same question but different method. Okay, so what I want you to do, I want you to create your Excel, okay, and do the Euler method and also do the Runge Kutta method. So try to get the similar answer in order for your understanding. No need to submit, but it's your understanding on how to use Runge Kutta. Okay, remember, if we go for final exam, something about that, we give you the function, you need to calculate manually, for example. So you need to have this C1, C2, and the rest. So for example, okay, the same question. First, solve this question in terms of Euler method. So you need to find the Euler method. So second, say with this Runge Kutta method, solve the issue, the problem. So you need to understand how to calculate the Runge Kutta method, especially because it related with 1 over 2h, 1 over 2c1. So in exam, maybe you need to calculate what is c1, what is c2, and the rest. Okay. So this is your task. Okay, no need to submit, but this is based on your own effort in order for you to understand the method. Okay, the method is important for you to understand. Not only for the subjects, you will use it in error analysis in any of the other subjects of numerical method. Okay, so I think it's already 120. So we will end at the Runge Kutta method. So I will provide you the next of a Taylor theorem and the rest by online for you to asynchronize, which should be on Monday, but I do it after this and upload to you for your understanding, and I will give you a tutorial for you to do. So we know that next Monday we will have a Wesak Day. It's a holiday. We don't have any class. but I will provide you tutorial for you to do it, for you to understand and submit before the next week Wednesday class. Okay. Any question?
Doctor.